Okay, let's continue on the activity. So previously we already calculated the delta turbulent. Okay, so we need to consider the laminar portion. So we need to know on the we need to calculate the xt first. Okay, and we know whether we need to consider the laminar region or not. Okay, so that is how we should do. Okay, and the next part is to get the wall shear, the tau knot at the middle of the flat plate. So the middle is just the x, the L divided by the 2. So 1.25 meters. So you want to confirm this, whether this is actually at a turbulent or the laminar region or boundary layer. So you can calculate the Reynolds number. You get this value is less than the 5 times 10 power 5. So it should be a laminar boundary layer. So here, on the way for us to get the wall shear stress for this laminar boundary layer, we can use the the boundary layer equation, that is the exact solution from the example 8.6.56. Okay, so we just put the Reynolds number, the density, and also the U infinity with the times 0.332. So you can get what is actually the tau knot at this section. So you know that this is actually a laminar boundary layer section. Okay, and the next part is to get the drag force. So in order for us to get the drag force, we need to know on the CF. Okay, so this is the combination flow, so you should use this equation. Okay, if they didn't ask you to derive, so you don't have to derive, so you just use the equation. So you just substitute the values given. Okay, because you know this is the REL. So this is the CF equation. On the way to get the FD, you have to multiple with this another part of this equation. Okay, so and just substitute back, so you know this is actually related to the Reynolds number. So L, okay, you have to know this is the L, so that's why it's REL. Okay, the total length is 2.5. Okay, because FD, the big CF, is actually related to the total thing. Okay, on the total length. Okay, total length, not total thing, total length. Okay, so when you get at one side, okay, this equation, so actually you have to multiple by 2 because we want to know on the both side of the plate. So it means the both side of the plate are exposed to the fluid. Okay, that's why we have to know the drag force on the both of the plates. Okay, so that is actually the related to this problem or the activity 5. Okay, this is all the answer that I have shared with you previously. Okay, and this is also another example in the activity. So this one I want you to calculate it because yeah, this part of your activity, and previously also I have another activity where I ask you about this submarine. Okay, to have a general knowledge about the submarine. Okay, and then the answer should be 280 kilowatt. Please double check on this. Okay, so this is actually just now previously also I have shown how actually this shape of the this submarine. Okay, so is this a laminar or turbulent or combination? When you calculate the Reynolds number, you know it's actually a turbulent. But how do you know whether you want to include or the laminar part or not? You find the XT. Okay, you can find the XT is much less than the 1/3 of the total length. That is, the total length is 50 meter. Yeah, it's very long. Okay, so actually you don't have to consider the laminar part. Okay, it's just a turbulent boundary layer. Okay, you can consider the boundary layer all total is actually a turbulent boundary layer. Okay, the submarine wetted area is actually the surface area of the cylinder, the shape of the cylinder. Okay, so you can get it. And then because when you calculate the Reynolds number is actually fall under the n equal to the 9. Okay, based on the Reynolds number. So this one also you can go back to the previous lecture notes or refer to the textbook. So how do you calculate the total power? It's just the drag force Fd times the cruising speed, that is the 8 meter per second, okay, of this submarine. Okay, so this is how you can calculate the wetted area, that is the scenic surface is of 2 pi d. Okay, and this is all the answer that I have given to you. So I think that's all. So I hope that you can try to get the answer of the FD is the total power, the P, okay, the power is 280 kilowatt. So I said please double check my answer. Okay, so this is all the the answer for the activity that I also already shared with you. Okay, okay, that's all. Thank you very much. Assalamualaikum.